In the spring of 1966, 5 blocks of Lower Manhattan wore a nickname that dated back to the 1920s, Radio Row. Along Cortlandt and Greenwich Streets, hundreds of small electronic shops sold vacuum tubes, radio parts, war surplus gear, and second-hand hi-fi from wooden bins stacked to the ceiling. Roughly 300 businesses crowded the 16-acre district, and 30,000 people worked inside its narrow storefronts. The Port Authority of New York and New Jersey wanted every one of them gone. In their place would rise the tallest towers on earth. The eviction notices went out, the lawsuits failed, and the wrecking crews moved in. Storefront signs came down, awnings were torn, and the bins were emptied into dumpsters. By the time demolition finished, 16 acres of Lower Manhattan had been scraped flat, an open wound of brick dust and bare lots, 4 blocks from the water. That water was the problem. The site sat at the western edge of Manhattan, a few hundred feet from the Hudson River, on ground that had never been solid. Much of it was landfill, centuries of rubble, ship ballast, and dumped earth that had pushed the original shoreline outward. Below the fill lay saturated sand and silt, and the river pressed against all of it, waiting. The ground was not empty either. It was honeycombed. Directly beneath the cleared blocks ran the tubes of the Hudson and Manhattan Railroad, the PATH trains, carrying tens of thousands of commuters between New Jersey and Manhattan every single day. Those cast iron tunnels could not be closed. Whatever the engineers built, the trains had to keep running straight through the middle of it. So before a single beam of the towers could rise, the planners faced a question that had nothing to do with height. How do you dig a foundation 70 feet down, next to a river, through waterlogged fill, without flooding the pit and without stopping the trains? The answer would not come from the architects. It would come from the machines. And it began with a hunt for something the site was missing: solid rock. On August 5, 1966, the ceremony was brief. Officials in hard hats turned the first shovels of earth on the cleared site. Cameras clicked, and the speeches promised a new skyline. But the men who actually understood the ground knew the truth. The real target of that first summer was not up in the air. It was 70 feet straight down. That was where the bedrock waited. Manhattan schist, a hard, mica-flecked, metamorphic rock formed hundreds of millions of years ago. It is the stone that lets Manhattan grow tall. Wherever the schist rises close to the surface, in Midtown and the financial district, skyscrapers cluster. Wherever it plunges deep, the buildings stay low. At the World Trade Center site, the schist lay roughly 70 feet beneath the street, and only that rock was strong enough to carry the weight of 2 110-story towers. Between the surface and the schist sat the enemy. 60-plus feet of loose, waterlogged fill, sand, gravel, old timber, brick, the buried debris of 3 centuries of shoreline. It held water like a sponge, and the water table stood only a few feet down. Dig an open hole in that material, and it would not stay a hole. The walls would slump, the sides would cave, and the Hudson, pressing in from a few hundred feet away, would fill the pit faster than any pump could empty it. Ordinary foundation methods were useless here. You could not simply excavate and then build a wall, because there would be nothing to hold the sides while you dug. You could not drive a cofferdam of interlocking steel through 60 feet of rubble, studded with boulders and old pilings. The engineers needed a way to build the wall first. A watertight barrier sunk all the way down to bedrock, before removing a single yard of earth from inside it. That reversal, wall before hole, was the whole problem. And the solution had already been proven in Europe, in the hands of an Italian firm, and a machine that dug blind, underwater, guided only by mud. The Italian firm was ICOS, based in Milan, and it had spent the post-war years perfecting a technique that turned mud into an engineering ally. Instead of digging a wide pit, ICOS dug the perimeter wall one narrow slot at a time. Each slot ran about 3 feet wide and 22 feet long, and it went straight down through the fill until the digging tool bit into schist 70 feet below. The tool was a clamshell, a heavy hinged bucket, hung from cables on a crane, its steel jaws dropping open and biting shut to haul up a mouthful of earth on each pass. But an open slot in wet fill would collapse the instant it was cut. So as the clamshell dug, crews kept the slot brimful of bentonite slurry, a soupy suspension of clay and water. That slurry was the secret. Heavier than water, it pushed outward against the slot walls with enough pressure to hold back the surrounding earth and the groundwater, propping the trench open from the inside without any bracing. The clamshell simply dug down through the mud, unable to see what it was doing, guided by steel guide walls at the surface and the sheer weight of the tool. When a slot reached bedrock, the crews did not pump the slurry out. Instead, they lowered a 7-story steel reinforcing cage down into the mud-filled trench. Then concrete was pumped in through a pipe called a tremie, entering at the very bottom. Being denser, the fresh concrete rose from below and displaced the lighter slurry, which was pumped off the top and reused in the next slot. Panel by panel, slot beside slot, the wall took shape underground. When the last panel was joined, the machines had built a continuous, reinforced concrete barrier, 3 feet thick and 70 feet deep, sealing the entire 16-acre site inside a single watertight rectangle keyed into the rock. From the street, almost nothing showed, but the wall was only half the plan. It was a box with its lid still full of earth, and now the diggers had to empty it. Now the excavation could begin in earnest. With the concrete perimeter locked into bedrock, crews brought in a fleet of clamshell excavators and began scooping out the fill from inside the ring. Load after load rose from the deepening pit. Sand, gravel, old timber, the crushed remains of Radio Row, and roughly 1.2 million cubic yards of earth would come out before the job was done, enough to bury a city block many stories deep. But there was a danger built into every foot they dug. The slurry wall had been designed with earth pressing on both of its faces, inside and out. As the crews hollowed out the inside, that balance vanished. The soil and river outside now pushed on the wall with nothing to push back, and a 70-foot concrete wall with millions of tons leaning against one side will bow inward and fail. The answer was the tieback. As excavations stepped down level by level, crews drilled long holes at a steep angle straight through the wall and out into the schist behind it. Into each hole they threaded bundles of high-strength steel cable, grouted the far ends deep into solid rock, and then tensioned them like guitar strings. More than 1,000 of these tiebacks anchored the wall to the very bedrock beyond it, holding the box rigid as its contents were carried away. And through all of it, the trains never stopped. The 2 cast-iron path tubes ran straight across the open pit, and as the earth around them was excavated, they were left exposed, wrapped and braced, running on a temporary structure through the middle of the largest hole in New York. Commuters rode from New Jersey to the World Trade Center site every day while, a few feet from the windows, machines tore out the ground. Foot by foot the pit went down, 7 levels deep, until the clamshells finally scraped bare the ancient Manhattan schist across the whole 16 acres. The bathtub had a floor at last, but all that excavated earth had to go somewhere, and the planners had decided it would become new land in the river itself. The excavated earth did not go to a distant dump. Just across West Street, on the Hudson shoreline, the Port Authority had a second project waiting for it. For years, engineers had wanted to reclaim land from the river along Lower Manhattan's western edge, and now the World Trade Center dig was producing exactly what such a landfill needed, more than 1 million cubic yards of fill. So the earth pulled out of the bathtub was loaded and moved to the water's edge, and much of it was dumped straight into the Hudson, behind a barrier of retaining structures. Load by load, the river was pushed back. Where there had been open water, A new shelf of made ground began to rise above the tide, held in place and slowly compacted into solid buildable land. That reclaimed ground became Battery Park City, roughly 90 acres of new Manhattan that had not existed when the digging began, born from the same schist-bound pit that would carry the towers. The material the machines tore out of one hole became the foundation of an entirely new neighborhood beside it. Nothing was wasted. The spoil became real estate. Back inside the perimeter, the bathtub itself was finished. 7 stories deep, floored on bedrock, ringed by its 3-foot concrete wall, and pinned by 1,000 tiebacks. The box now did exactly what it had been built to do. It held the Hudson out. Water pressed on every side, and the wall did not yield. By 1968, 2 years after that first ceremonial shovel, the foundation stood complete and dry, an enormous empty basement waiting on solid rock. For 2 years, the machines had worked almost entirely below street level, and to a passerby, the 16 acres still looked like a hole in the ground. But that hole was the hardest part of the entire project, and it was now behind them. The river was beaten, the rock was exposed, and for the first time, the builders could stop digging down and start reaching up, because the towers themselves were about to be assembled 3 stories at a time on the ground. By 1968, the bathtub was done, and the towers could finally reach for the sky. But Minoru Yamasaki did not want the wide, dark windows of a typical skyscraper. He was afraid of heights, and he designed for people who felt the same. So he wrapped each tower in a cage of narrow, vertical columns, spaced just 22 inches apart, framing windows barely wider than a man's shoulders. There were 59 of these columns on every face of each building, and together they did something radical. They carried the load. Leslie Robertson's engineering turned the exterior wall itself into structure. The perimeter columns and a dense core would hold up all 110 floors, leaving the office space between them open and column-free. But 900,000 tons of steel could not be riveted together piece by piece, 70, 80, 90 stories in the air. Yamasaki and Robertson had a better idea. The columns would be built on the ground. In fabrication yards far from Lower Manhattan, crews welded 3 of those slender columns to 3 horizontal spandrel plates, forming rigid steel modules 3 stories tall and roughly 10 feet wide. Each one weighed as much as 22 tons. Every module was a puzzle piece, machined so its bolt holes lined up with the piece beside it and the piece above it. The staggered pattern meant no 2 neighboring modules had joints at the same floor, spreading the seams and stiffening the wall. Painted, numbered, and stacked, they were trucked into Manhattan on a schedule tight enough that steel arrived almost the hour it was needed, because there was nowhere on the 16-acre site to store it. What rolled off those trucks was not raw material. It was a finished section of skyscraper, ready to bolt and weld into place in minutes rather than days. The engineering had solved the wall. The fabrication had solved the assembly. Only one question remained, and it was the oldest question in construction, made new by the sheer height of what they were building. How do you lift a 22-ton steel tree a quarter of a mile into the air? The answer came from the other side of the world. In Sydney, a company called Favco built tower cranes unlike anything on an American site, and the men at the World Trade Center gave them a nickname that stuck: the Kangaroo cranes. 4 of them would raise the Twin Towers. Each Favco crane did not stand beside the building. It stood on it, bolted to the steel of the rising floors. A Kangaroo crane perched inside the structure it was helping to build, its lattice boom swinging out over the edge to pluck each column module off the truck and set it into the wall. And when the steel around it grew taller than the crane itself, the crane climbed. This was the trick that gave the machines their name. A hydraulic jacking system gripped the tower's frame and hauled the entire crane upward, floor by floor, so it always sat near the top of the work. It jumped like the animal it was named for, lifting itself roughly 2 stories at a time and then reaching back down to build the next 2. Each crane could hoist near 50 tons and swing a full circle, feeding steel to the gangs of connectors who bolted the modules and the welders who sealed them. From 1968 onward, the four kangaroos worked the North Tower and the South Tower in a slow vertical race. On a good week, the steel rose 3.5 stories. The columns that had been welded on the ground now stacked into the sky, each 3-story module locking into the staggered seams of the one below, the wall thickening into a tube strong enough to stand against the wind that howls 1,000 feet over the harbor. Crowds on the street below watched the booms turn against the clouds, the loads hanging like ornaments over the pit that had swallowed 2 years of digging. Higher and higher the cranes jumped, until the 2 frames began to close on the same milestone every builder waits for. Somewhere near the top, the last piece of steel was already waiting to go up. On December 23, 1970, that last piece went up. A final steel column, painted and signed, rode a kangaroo crane's hook to the roof of the North Tower, and at 1,368 feet, it topped out as the tallest building in the world. 7 months later, on July 19, 1971, the South Tower reached its own summit at 1,362 feet. 2 towers, 208 feet apart, now stood against the sky, where Radio Row had been cleared 6 years before. But a topped-out frame is not a finished building, and getting people up a quarter of a mile of stairs was impossible. The towers needed to move crews, materials, and one day 50,000 office workers vertically, fast. The solution was borrowed from the subway. Otis built an elevator system that treated each tower like a stacked city. Sky lobbies sat at the 44th and 78th floors, and express elevators shot straight to them at 1,600 feet per minute, nearly 27 feet a second, in barely a minute. From those lobbies, banks of local elevators fanned out to serve the floors above. Because 3 shafts could share the vertical space one traditional shaft would need, the design freed thousands of square feet on every floor for rentable office instead of elevator machinery. During construction, those same shafts became arteries, hauling workers and the endless supply of aluminum cladding, glass, drywall, and pipe up to the crews finishing the interiors behind the steel. Now the exterior could be closed in. The prefabricated columns were sheathed in bright aluminum alloy, and glass filled the narrow slots between them, one tower turning silver from the top down, while the other still climbed toward its own skin. Inside, 110 floors were wired, plumbed, and partitioned. What had been an open steel cage in 1971 was becoming, floor by floor, the finished complex. All that remained was the day the city would stand at the base, look up the full height of both towers, and call the work done. That day came on April 4, 1973. Governors, dignitaries, and the men of the Port Authority gathered at the base of the Twin Towers for the formal dedication, and above them rose 110 stories of steel, aluminum, and glass that had not existed when the decade began. It had been almost 7 years since August 5, 1966, when the first shovel bit into the fill of Lower Manhattan. Now the numbers stood finished. 2 towers, each roughly 1,360 feet tall. 10 million square feet of office space. 200,000 tons of steel, held up not by a heavy internal skeleton, but by that revolutionary cage of exterior columns built on the ground and lifted by the kangaroo cranes. 250,000 people would soon pass through the complex each day, riding Otis Express elevators to the sky lobbies, working behind the narrow windows Yamasaki had drawn for people afraid of heights. The 1,000,000 cubic yards of earth pulled from the pit had become new land in the Hudson, the ground beneath Battery Park City. And far below the dedication crowd, unseen and unmentioned in most of the speeches, sat the thing that had made all of it possible, the bathtub. The 3-foot slurry wall the ICOS machines had cast in the mud, anchored by tiebacks driven into the schist, still held the river out of the 7-story basement. The first 2 years of this project produced nothing anyone could photograph as a skyscraper. They produced a hole, a wall, and a foundation on bedrock, and only after that could the steel climb. The towers that dominated the skyline were the visible half of the achievement. The invisible half was the trench dug 70 feet down, while the path trains still ran through the pit. That is the real story the machines wrote into Lower Manhattan, and it is the line this film leaves you with. What rose here was made possible by what was dug here first. 7 years from bedrock to sky,